So the first startup on stage is Enkitek. Please welcome on stage Victor Canton Ferrer from Barcelona, Spain.
Hello, everyone. Thank you for being here. So I guess you all have already heard about that in 2050 we will have like 10 billion people, and 2/3 of them will be on the big cities. So a big problem is ahead. They say that the experts say that there will be not enough food for everyone. And as an Enkitek with philosophy, we want to fight for that. Okay, so we have found that vertical farming and indoor farming, maybe you don't know that, but this sector, but they are able to grow vegetables, so food inside the cities, so a low carbon footprint, and they can be more productive than extensive farming because they are producing all the year round. And they are using more effectively the water and so on. So Enkitek, it's a software company for agri-tech. So what we want to do is to provide the tools for vertical farmers to be more profitable, so they can grow more and more food and be the key for having more sustainable food for 2050 and avoid this lack of food that they are forecasting. So change. So one of the main pain points of this sector is the high cost of the operations, because 56% of the operation costs are linked to the manual operation, because indoor farms can be suited in a warehouse, in a building block. It can be suited anywhere. In fact, for instance, in London, there is a vertical farm, huge vertical farm in the center, in the shelters of this World War II. And it's inside the city, and they're producing lettuce and basil and many other vegetables, and they are serving the center of the city. So even with bicycles, so the carbon footprint is so low. So we want to be a driver for them to be even more profitable, reducing these pain points. So we have done a software platform that is able to control this kind of robots. That's why we have bring this. We are not a hardware company. What we do is we find the best suitable hardware we can find on the market on the right moment for the customer. And each customer is different, so every customer has different needs because there is not much standardization here. Also, we want to help there. So with our software platform, we are able to control this kind of robots. We are hardware agnostics, so we can use this robot, but tomorrow we can use another robot because we are using a very cool software platform. It's called ROS, Robotic Operating System. So we can exchange the hardware we need for each use case. So in this case, we will show you how we are able to control this robot without the controller of the robot. So we will control it. If everything it's okay. Borja, can you unlock the computer? Thank you. So we will be controlling the robot with this software platform. We will be controlling this device here to look for the strawberry. In this case, it's the plastic strawberry, to not mess that up. And we will find this strawberry with an artificial intelligence model, a deep learning model. So we can teach any use case for any kind of vegetable. Let me take one. Okay, so also with this software platform, we can interact with the whole indoor farm to interact with sensors, with actuators. So we can take all the automation needed for the indoor farm. And the last one, the MES part, we are able to digitalize the whole operation. So, okay, here you can see that it's going to pick up. It's just a demonstration that we are able to do this kind of setup for any indoor farm. So we'll try. So no matter the position, maybe it's a little bit small for you, but to see. But you can see here what the camera is seeing. It's looking for the strawberry, and then it's calculating the distance between the gripper to the strawberry, and it's calculating all the joints, all the movement that the joints needs to be changed to make that movement. So it really is not a typical industrial application that you would use just the controller of the robot. So we are doing everything in software, and so maybe also not just the robots. We can also use only cameras to monitor the growth of the plants. So we can follow up a lettuce, let's say, and see, okay, here we have a pest, here we have a disease, or even we can check the growth ratio of the vegetable. So if we see that one vegetable is at 70% of their growth, and they should be at 90 because all the operations are digitalized, so we can advise the farmer to go there and to change something. For a small farm, this make no much sense, maybe, because people, okay, if you have just 50 square meters, but if you, these indoor farms are getting bigger and bigger, you can have a warehouse like this building with a lot of shelves until the ceiling. So you can imagine that it's hard to monitor what's going on in each tray where the vegetables are growing. So right now, there is no more strawberries, so I stop it. And I think I'm just 10 seconds away from my time. So thank you very much for your attention, and I hope you like our value proposition. Thank you.
All right, thank you, Victor. So, time for some Q&A. Please raise your hand. Maria and Raul will have microphones, and they will go to you. Also, as you consider Victor's presentation, I will remind you to please vote on Slido. You can, Maria, sorry? Up here in the front. Just Google Slido, enter the code machine demo, or vote through the app. First question.
Thank you for the presentation, very interesting. My question is, does the farm need to have the robots already and you just provide the software?
Yeah, yep, sorry. So the needs of the indoor farms depend on each use case. So if they are a very small farm, they will maybe not need this kind of robot. So this is just for them. Also, it's quite small. So it's for us to program it and so on. But for medium-sized or big-sized indoor farms, where they have a very full capacity of production, and sometimes they need a robot. So we are not hardware providers, and we are not building this robot. We go to the market. We have the experience to work with hardware integrators to define exactly what they need. So the customer, it's buying the hardware to any hardware integrator, and we make sure that we integrate with our platform and put the intelligence that the hardware integrator cannot put, or they are not so able to do that. So because we are dealing with plants, not with screws or industrial parts.
How many of those farms can afford those robots?
Yeah, right now, the big ones already do their own integrations. So the middle size, for instance, I would say in Spain, right now we have like 3 players that may use this kind of robot. Not this one, this is very small, but but that's why we have the full automation spread. So not just robots, also monitoring with cameras and all the digitalization. So this is just 1/3 of our proposition. Thank you for requesting.
One more?
Hey, my name is Sergio Vieira, quite interesting. Could you expand a bit more on the scope of your platform? Meaning if your value proposition is tackling controlled environment variables like CO2, nutrient optimization in terms of electroconductivity, pH, and specific nutrients. Well, can you expand a bit more on the scope?
So we have the robotics, the sensorics, and the digitalization. The digitalization part of our solution is where the power is, because it is done in a way that it's quite generic, and each indoor farm can set up the layout, the recipes, for each process, the parameters they want to control, and so on. And then with sensorics, we can link this. So with this, they can do 2 things. They can make the production planning, all of the typical operations that right now they're doing by Excel sheets or even by hand. So it's a very young sector. but also with that, they can, as I said, they can look for the problems, but they can also create problems. Let me explain. So they can make experimentation. For today, for example, the cost of the energy is getting higher. So they can say, for this batch of vegetables, I want to controlling the light, because we are able to control the lights. I want to reduce the power output of the lighting by 10%. And then the packaging, we have the weighting of the output. So we can check the output affection of changing some parameters. So they can say, okay, now I'm saving a lot of $100 in power, but it's not affecting so much the output. So they can make also experimentation. So it's operation tracking and experimentation for improving. So at the end, they get more insights of what's going on their operations.
Okay, thank you, Victor. Let's give one big round of applause for Enkitek. Thank you for the demo. Thank you also for the questions.